This is an AQA GCSE chemistry question. It's the Trilogy 2019 paper and it's a higher tier question. This question is about crude oil and I'm going to give you a chance to pause on each section, have a go for yourself and then review. So here is part A, parts B and C, and finally part D, a 10-mark question in total. So let's take a look at part A. Hydrocarbon fuels are produced from crude oil. How is crude oil separated into fractions? It's a very, very commonly a 4-mark answer on this one. And there are key points of fractional distillation that you need to come back to, but the answer can be very concise. You heat or vaporize the crude oil. Now we know that's happening down at the bottom of the fractionating column. And the fractionating column is therefore hotter at the bottom or cooler at the top. You don't need to say both, but we do need that in there. We also know that after evaporation, we have condensation. So the vapour condenses. But we're not yet talking about how we're separating them. And longer chains will condense lower down the column where it's hotter, whereas shorter chains can rise higher up the column before they condense. And it's those steps that allow us to separate crude oil into the fractions. Looking at part B, we have got two equations for the combustion of butane. Why are there different products formed? Well, there's two ways of looking at this. One, you can remember the product of complete and incomplete combustion. Two, you can simply look at the amount of oxygen. We've got 13 moles of oxygen in the first one, only 5 in the second one. So the second one is incomplete combustion, and it's because there is a limited supply of oxygen. We've also got the option of making carbon monoxide in incomplete combustion of butane. So let's have a look at the balancing of this. Now, whenever I balance hydrocarbons or combustion of hydrocarbons equations, I follow the rule of Cho. I balance the carbons, then the hydrogens, then the oxygens. So I've got C4, so I need 4 CO. I've got 10 H's, so I need 5 H2O. That now gives me 5 plus 4, 9 oxygens, which means I need 4.5 O2. To finish off part D, describe the greenhouse effect in terms of the interaction of short and long wavelength radiation with matter. It's a very specific answer that you need here. Some very key details in this topic that you are going to have to remember. So, short wavelength radiation enters the atmosphere. It comes from the sun, comes into the atmosphere, at which point it's absorbed by different materials. It's absorbed by the earth, and then it is re-emitted. We're on the second mark there with both of those points. Now, when it's re-emitted with a longer wavelength radiation. The reason that this is an issue is that that longer wavelength radiation is then absorbed by greenhouse gases. It's absorbed by carbon dioxide, by methane, which means it doesn't escape from the atmosphere. It's trapped in the atmosphere, causing the atmosphere's temperature to rise. And that takes us to the end of this question.